Hi everyone. This week we are learning about the OSI model, which is really the foundation of all networking. This specifically applies to our chapter that we're covering in Net 125, but it also applies for almost every level of networking, no matter how basic or foundational or advanced we get. So our objectives are explain why the OSI model is important, explain the 7 layers of the OSI model, the responsibilities of each layer and why and how they're connected, and explain the advantages and disadvantages of using a layered approach to networking. So the OSI model in general is the Open Systems Interconnection Model, or abbreviated OSI. It provides a framework for end-to-end communication between network devices. So as you kind of go up and down these layers that you see there in the image, we are really, if you're at a source and a destination, kind of like those computers in the far upper left-hand corner and the bottom right-hand corner of the image that you see there on the screen, as we go from one device to the next, we are really traversing these layers down and up. So as the source sends something, you're starting at the application layer and going down to the physical layer. And as the receiver, the destination, receives it, they're starting at the physical layer and going back up to the application layer. So this process happens continually back and forth as you communicate from your PC to another PC, as you check your email, as you access a website like ESPN.com or anything that you're doing, any application that you're running, or any service or process that you're using on your computer that has networking capabilities. So this is very important to software developers. It consists of 7 modular layers, so they are each in their own individual right a separate layer, and it's the OSI is application developer software engineer's best friend, because again you have to decide what type of what is going to happen at each one of these layers as you implement these. And let's say if you were on the team for developing Microsoft Word, right, then you have to know at what point in these layers do you want to choose certain protocols to happen. If you are an online game developer, one of the most important things you'll see is that the transport layer, you have a determination to either make it use UDP or TCP. UDP is used a lot because, again, and we'll explain that as we go through these slides, but UDP is a popular choice for online gaming. So the 7 layers of the OSI model, the top-down approach is, again, at the source. When you kind of go down these layers here, you're starting at the application layer. It passes its information to the presentation layer. The presentation layer passes its information to the session layer. Then it passes its information to the transport layer, and so on through the network layer, the data link layer, and finally the physical layer. It'll hop on the kind of the physical equipment, which includes the cables, the router or switch that you're running through. It runs all the way to the destination, and then it goes from the bottom up. It leaves the cable or the router or switch and goes through unpacking. So as it goes from the top down approach, that's the kind of way that I like to learn it. The application, presentation, session, transport, network, data link, physical. As it goes through each one of those, it is what's called encapsulating more and more information around your data. As it goes from the bottom up, it's basically unpacking that information little bit by little bit and peeling those layers off. So you can kind of think about top down as adding layers like an onion. On the other side is peeling off those layers. So some mnemonics that you can use to kind of remember at least the first letter of each one, if you're using the top-down approach, is all people seem to need data processing. So that way you can just quickly write down the first letter, kind of like if you're doing the order of operations with please excuse my dear Aunt Sally for parentheses, exponents, multiplication, division, addition, subtraction, right? So you want to make sure to do that with this as well if you're having trouble remembering the layers. Or if you use from 1 to 7, please do not throw sausage pizza away, right? So I know that would be terrible in my house. My son loves pizza, right? So again, if you're going from 1 to 7, please do not throw sausage pizza away. And then even another one, again, please do not touch Steve's pet alligator, right? If you're reading it from 1 to 7. So just depending on which one, there are, hundreds of these out there. Just pick whichever one helps you best. I seem to like the 7 to 1, where all people seem to need data processing. But again, it's just to help you remember the first letter. So application, presentation, session, transport, network, data link, physical. Now, there are tons of connected devices today. So if you're using where you're using a computer, laptop, desktop, tablet, if you're using your refrigerator to order groceries off the front panel that is connected to your Wi-Fi, or your smartphone, right? Or you've got smart thermostats, you've got smart coffee pots. There's all types of things. I remember when I was in college, my professor always joked that one day we would have, toasters connected to the internet. And I'm sure there are probably smart toasters out there today. And they all still follow this same OSI model with communicating with the internet. So again, human versus machine communication. When you think about it, you always have a source and a destination. The message source can be your computer, and the message destination will be another computer, a web server, the email server you're checking your email off of, or whatever it happens to be. Same thing in human communication where you're talking from one person to the next. The signal, right? That transmitter that you're using is, depending on if you're using, like in machine communication, it could be an Ethernet cable, it could be Wi-Fi, or whatever it is. Each one of those signals are different. Wi-Fi uses radio frequency. Fiber optic cables use actual light transmission, pulsing on and off. Ethernet cables use voltage, either on voltage or off voltage, to represent zeros and ones in computer language. Same thing with human communication. If you are speaking a certain language, the air is the transmission medium there, where the cable would be the transmission medium for computer communication. So you can kind of see that you have to have a receiver, right? That receiver has to know and understand what language you're talking about. So the OSI model is important because it helps standardize that language. Just like with anything in computer or in technology in general, there usually are a lot of standards. Like if you are old enough to remember when there were VHS tapes, right? After VHS tapes for movies, there became DVDs, there became Blu-ray, there was a lot of different options there, right? So now there's kind of a standard where you have digital movies and now Blu-ray, right? DVDs are not as popular as much anymore. So there usually involves a lot of different standards, and then the industry kind of shifts and shakes it out to just a few. So the OSI model helps shape that standardization. So in human communication, you want to make sure that the sender or the message source and the message destination can both understand each other with the same language. Same thing with computer communication. So the first layer is the application layer. All right. Remember, it is the actual application or the PC that you're using. It accesses that underlying network service. You are interacting with the application layer. So it could be like an email interface, remote file transfer, name resolution, any of those. So some of the protocols you'll see are like HTTP, you've seen that, or HTTPS, you've seen that when you type in a web browser. DNS for domain name service, because again, when you type in ESPN.com, it is going out and finding what IP address does that belong to. FTP for file transfer protocol, SMTP for checking your email, simple mail transfer protocol. There's a lot of them that operate at that layer. It's not totally, we don't have to totally understand each one and why application developer would choose it. But again, this is the application layer that starts that process at the source. The next one after the application layer, it passes it down to the presentation layer. The presentation layer is responsible for processing that message data from the application layer and formatting it appropriately, which includes encrypting it or decrypting it, depending on if you are the sender or the receiver. It's really concerned with the syntax or semantics. So how is this message written? It displays the information exchange between the two systems and kind of packages that and gets it ready. If there's any compression that needs to happen, like for instance, if you're sending an MP4 or an MP3, all right, that's a specific type of compression for that movie or music that you're listening to. It frees the application layer from really worrying about the format, and it can focus on just the data. So then the presentation layer sends it down to the session layer, and it gets encapsulated or kind of boxed in with more information. It actually manages the sequence and the flow of events, so it gets it ready to be sent. It's built-in support for multiple types of connections, but the session layer is getting it ready to actually like synchronize between the sender and the receiver, or source and destination, between the two systems, right? It starts up that dialogue that's required between both ends to say, hey, are you ready to receive? And hey, are you ready to send? Okay. It also helps create a recovery scheme if the connection is lost temporarily, because sometimes you do need an end-to-end connection to be established and maintained and no interruptions happen. As it passes it down again, you get to layer 4, which is the transport layer. Now, the transport layer is very important. This is what I was talking about before. If you are a software developer for like an online game, you have to either choose here, and this is for any software developer, TCP or UDP. TCP is a reliable connection-oriented delivery method where it sends and receives information in order. Right now, if it sends it out, it can't be responsible for how it arrives, but once it arrives on the other end, TCP will reorder all the packets to make sure they're delivered in the correct order or reassembled in the correct order. It also maintains what's called a three-way handshake at first, which basically says, hey, are you ready to receive the information? The destination says, yes, I am. And the receiver says, okay, now we're about to start transmitting. So that creates that facilitation of a connection-oriented, flow-controlled, very detail-oriented packet exchange. Now, if a packet or something is lost along the way, it will also say, hey, I need you to resend this amount of packets, whatever numbers are missing. Okay. UDP is the exact opposite. UDP is best effort. It is unreliable and connectionless. So it does not do the three-way handshake. It just sends it out. If it gets there in order, great. If it doesn't, then oh well. So it is like, you're probably thinking, why in the world would you even use that? Well, in real-time communication, live streaming stuff like an online environment for a video game with online worlds where people are interacting together, or if you are using like Skype or any video conferencing type software, that is needed in a UDP format because one, it's quicker, it has less information added in there, so you don't have numbered packets and all that stuff necessarily to keep track of and everything. So it's less overhead, which is less data to transmit, so it makes it a little bit faster. But again, it's no time for that. So in an online video game environment, that's why sometimes you'll see people walking on one side of the map. You may like glitch or lose connection for a minute, and then you end up like somewhere very far in between because UDP is not resending those packets that were lost along the way. But it is important in a live streamed environment like that, that you don't have time to go back and resend packets. So UDP is very popular there. So at transport layer, no, you've either got two choices, TCP or UDP. The network layer is very important. We say routing happens here at layer 3. The network layer is where routers really get involved. They are responsible for either an IP version 4 or IP version 6 address. You can see the examples down there. IP version 4 addresses are separated by periods or dots, so it may look like something like 192.168.1.1. IP version 6 addresses are separated by colons and they're much longer. Why the difference? IP version 4 was developed a long time ago and we've basically ran out of addresses. There are around, I want to say, a little over 4 billion IP version 4 addresses. Don't quote me on that number, but I believe that's what it is. But again, there are more devices that need IP addresses out there than there are addresses available. So all the different registries like the American Registry of Internet Numbers, or ARIN, and all the ones around the world have kind of basically ran out. So many years ago, they decided to implement IP version 6, which has around 340 undecillion possible addresses. So that's like the number 340 with a lot of zeros after it. I want to say it's 32 zeros to follow. So again, you can kind of see the difference there. We should never run out of those. So network space is kind of what we quote unquote say unlimited with IP version 6. But again, as we get more connected devices, we start to use up that space. But it's pretty future proof. Let's just put it that way. So again, it opens and maintains that path between networks. Okay. Now, the data link layer is responsible for MAC addresses. This is where we say switching happens because switches are very concerned with MAC addresses. MAC addresses are your social security number for your computer almost. So it's like identifying your specific device to your computer because it is unique to your internet card. So your network interface card, either through Ethernet or Wi-Fi. Okay. So it is responsible for error control and detection and delivering it specifically to your device. So also at the network layer, we call these packets. Okay. At the at the data link layer, we call these frames. At the physical layer, that's the last one, layer 1. This is where physical equipment gets involved. So cables, the actual device itself. And again, for fiber optic, we might use light voltages. So a pulse of light is a 1, a non-pulse of light or absence of is a 0. Wi-Fi uses radio waves. Voltage is used by, like electrical voltage is used by Ethernet cables. So if you see voltage or feel that voltage, then that means a 1. If there is an absence of voltage, that is a 0. And this is where all those zeros and ones take place in computer language. And this is responsible for moving those individual bits, and everything is called a bit here at the physical layer. Now, what are the advantages of this layered approach? We have greater compatibility between systems because, again, this is a standard that all systems will use. It is increased flexibility. It is scalable. It's modular. And again, scalable meaning we can take and create it. We can add a lot of different devices for the different networks and make them as large or as small as we need to. They are modular, meaning they are independent. So if, like, for instance, with layer 3, it is concerned with IP addressing. We were able to seamlessly integrate, for the most part, IP version 6 without interrupting, all the rest of the layers. So one instructor explained it to me like if you were flying in an airplane, right? You've got all these boarding procedures, you got takeoff procedures. So a lot of times they board you based off of zones, right? So if you paid extra for zone 1 or board early, then, it really wouldn't change how the pilot flies or anything else. So if they all of a sudden decided to say, hey, we're going to now board you from shortest to tallest or tallest to shortest, it wouldn't change what the pilot does to get ready to fly. So each one of these processes are individual and modular in their own right. It also tries to simplify a large and complex system because it basically tries to break down all that's happening in a system as large as networking or the internet. Now, the disadvantages are, again, it does add processing and data overhead. Just as we mentioned before, TCP versus UDP. TCP has more overhead, so it does make it slower. And all this encapsulation does add data every single time. There is at least one protocol standard per layer, so you do have to learn some protocols and what's going on at each one. And it does increase latency because more data to process, more standards to process. Latency is basically that delay time in networking. All right. Now, again, I want you to try to reassemble those top-down approach using layer 7 as the top layer and layer 1 as the bottom layer. This is just an activity you can do on your own, in your own brain, write it down to see, and again, use those mnemonics as you go through it.